Okay, for today's lesson, you're going to need the workbook. We're going to be in chapter 3-2. That is on page 172. Okay, so page 172. All right, today starts off with functions. We're going to look more at functions here, real life applications. Example 1 up here states, a 10,000 gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool and into this tanker. How can you determine how long it will take to pump all of the water into the tanker? So we have a pool. It says it starts with 10,000 gallons. 2,000 gallons have already been pumped in there, and we see it's being pumped out at a rate of 720 gallons per hour. Okay, so going down and trying to understand this problem a little bit more here, we see the amount of water already pumped is our initial value, our y-intercept. So again, the y-intercept is where it's going to touch the y-axis there. And that 2,000 represents the gallons that have already been pumped. And then we see a unit rate here of 720. So from every hour, it's going to increase 720 that's being pumped out. Okay, this is what we call a linear function. All right, the graph that it makes a straight line. So it is linear, and it's also called a function. Okay, now a function is something that could be linear. It doesn't have to be linear, but to tell if it's a function, one way is you can apply a vertical line test to it. So if you take an object such as your ID, and if you hold it along whatever you graphed, it should only intersect that function at one point. So no matter where I move this ID here, it's a vertical line, it's only going to touch that line at one point. So that's a way to tell that it passes the function test. That's called the vertical line test. Okay, so let's go down to the try it. So the try it states, as the pump is pumping the water, the amount of water in the pool decreases at a constant rate. Complete the statements below. The amount of water remaining in the pool, so they had 10,000 gallons and they took out 2,000. So the 10,000 minus 2,000 means we have 8,000 gallons left in that pool. Okay, if I go over to the graph, 8,000 is my starting point. So I'm going to go ahead and I'm going to plot that point over there. And if we look at the graph there, this is 7,500 and this is going up to 9,000. So if we look at this, it's not 500 every time there. So the graph is going to be not quite on the corner of a box. But we're going to kind of guesstimate where 8,000 would be. Okay, the amount of water pumped each hour is 720 gallons. And then the equation. So an equation that we come up with this, we could say y equals, and if we take the amount that you start with, 8,000, and we add the unit rate. Now, it's being pumped out at 720 gallons. So 720 is negative because it's coming out of that pool. And then we have to add our variable on here. We can use x. You could use t for time. You could use h there. It really doesn't matter what variable you use. So our equation would be y equals 8,000 minus 720x. Or we could flip that around. We could say y equals negative 720x plus 8,000. Okay, so they want us to go ahead and make a couple more points on here. So I'm going to go to hour 2. And to figure out how much water would be left in that pool, we start with 8,000, but we're going to take out 720 gallons per hour, and if 2 hours goes by, then I'd multiply that by 2. So I could run that on my calculator, and I typed in 8,000 minus 2 times the quantity 720 equals 6,560. So I would go up here, try to find 6,560, and it might be roughly there. All right, let's try that for 4 hours now. So same thing, 8,000 minus 720 times 4. Now I can go up to my calculator here, and if I hit that up arrow, I can keep that same equation, but what I'm really changing though is just the hours. So instead of the 2, I know it's 4, so I can just change that 2 to a 4, leave everything else the same, push equals, and here's my new amount. So in 4 hours, there's only 5,120 gallons left. So the dot be somewhere close to that. Okay, I want you guys now to go figure out what it would be for 6. And then plot the point. Okay, figure out what it would be for 8. And then plot the point. Okay, after you have all your points on there, then you can use your straight edge, and we can connect the points here. And we would have a line, something similar to this. So we can guesstimate that our pool is going to be somewhere emptied around 11 minutes. It looks like it's not quite, but it's going to be very close, around 11 minutes there. Okay, going on to example 2. How can you determine whether the relationship between side length and area is a function? So if we look at a table, we set it up. This first column is really our x values. And the x values are what we call our input values. Over here, second column is our y values. And the y values are the outputs. So this is an input-output table there, or an xy table. And it's asking if this is a function. So to determine if it's a function, we look at all the x values. Okay, and if you look at the x value should only have one output value, meaning 0 can only go to 0. It can't go to any other number. We see 1 only has one output value. I plug in 1, I only get one number that comes out. I plug in 2, I only get one number that comes out. Same with 3, same with 4, same with 5. So every input only has one output value, so that is why it's a function. Okay, if we were to graph these points, we go over here, and we see it's a function, but it's not linear. Okay, so this is an example of a nonlinear function. But again, if I take something that's vertical, such as your ID, and I hold it anywhere along that graphed portion, it's never going to go through that line or that nonlinear function there more than once. It only touches there at one point, no matter how I move that. So it passes, we could say it passes the vertical line test. So that's another way to tell if it is a function. Okay, going on to example 3. This is determine whether each of these represents a function. Again, probably the easiest way to do it is to see, does it pass the vertical line test? So no matter where I move this, it passes the vertical line test on this first one. It is not linear because it's not all in a straight line. All right, it's like half of a straight line, half there, but it's not one whole straight line. So this is a nonlinear function. If I go over here, again, it's definitely not linear, but no matter where I move that, it's only going to pass through there at one point. So this is also a function. If I go to this last one, and I think you can see where I'm moving it here, and they even put a point there. If I drew my vertical line right there, it's touching at 2 points. So because it's touching at more than 1 point, this is not a function. Okay, that's it for today.